Hi, this is inverse function video part 2. We ended part 1 by talking about misconceptions about inverse functions, and we ended the video saying that inverse functions simply means switching the x and y input output, and we're gonna talk about this more specifically with the inverse of trig functions. So we agreed the trig functions, the six ones we talked about, which are sine, cosine, tan, cotan, secant, and cosecant, we agreed that those three are the reciprocal and they're not inverse. And the way we represent the inverse would be using this notation of a superscript of a -1. But again, this does not mean a power. That's just to recap. Now, how are we going to apply this using the unit circle? And as you see, I have the negative radian unit circle right here ready for us. So in the previous section, we learned how to find the sine of pi over 6. And let's together try this. I go to pi over 6. Sine is the y coordinate. So I find sine of pi over 6 equals half. In today's objective, here's the question. The question is going to be, what is the inverse sine of half? And according to the idea of inverse, we are switching x and y. So this will make it pi over 6. Now, it's important to understand what does this mean in words. So we're going to write it in words together. This means which angle. So for all of those, the answer, which is the output, is going to be an angle on the unit circle. And we said by convention, we give our answer in radian unless the question asks us to give it in degree. So which angle has sine equal half? In other words, which angle has y coordinate equals half? So I go on the unit circle and I know that sine is the y coordinate, and I look at all the y coordinates and I find two of them. And I look at the angle, I'd say, oh, pi over 6 has a y coordinate equals half. 5 pi over 6 also has a y coordinate equal half. But we have to be careful because with inverse, we're going to introduce something called range of an inverse function. And I'm going to erase right here to talk about the range of inverse functions. So the range, we're going to talk about inverse sine, inverse cosine, and inverse tan. So I'm not allowed to work with the whole unit circle when I'm working with inverse. I just can work in between -pi/2 and pi/2 for sine, 0 and pi for inverse cosine, and also -pi/2 and pi/2 for tan. So -pi/2 and pi/2. What does that mean? So the range right here is 0 to pi. I'm only allowed to look at the first and second quadrant when I'm using inverse cosine. I'm only allowed to look at -pi/2 to pi/2, which means fourth and first quadrant. So 1 and 4, 1 and 2. For inverse tan, very similar to inverse sine, except if you notice I put open circle, which means -pi/2 and pi/2 are not included in the range. And that's because if you guys remember, when we look at -pi/2 and pi/2, if we try to find the tan 1 over 0, -1 over 0, tan is undefined at those 2 points. So I am not allowed to include those two in the range of inverse tan. Let's take another example. So if I say, what's the inverse cosine of -1? In words, I'm going to write this down. Which angle has cosine equals -1. In other words, which angle has x coordinate equals -1. And the first thing I want to think about is writing this inwards, which I just did. The second thing I want to think about is where am I allowed to look? I'm allowed to look here to here. So I look at the unit circle, only 0 to pi, and which angle has an x coordinate equals -1? It's angle pi. Remember, our answer with inverse is always an angle. So now we know how to reason about inverse cosine and inverse sine.